Students, this is a help video for the take-home practice quiz for the half-chapter quiz, Unit 7. This, you want to make sure that you work through problems 1 through 20. Do that in pencil first. And then you're going to correct in red pen. And then you're going to do problem number 20. Accuracy does count on that last problem. Make sure you show all your work. And when you come and you actually take your half-chapter quiz, it's going to be 2 separate items going on. One's going to be a team quiz. You're going to have about 3 multi-step problems. You're going to be allowed to work together with your quad. If your complete quad is not here, you'll be assigned quads. That's going to be 25 assessment points, 18 points for the actual work and accuracy of what's going on, 3 points for a peer review on effort and participation, and 4 points for the interview by the teacher of the quad mates. Individually, then that'll be followed up by an individual quiz. There'll be 10 problems, similar to the ones in this packet. Accuracy will count. You will not be allowed to use any notes or other aids. That's going to be 30 minutes and 15 assessment points for a total of 40 assessment points. All right, so for these ones, we are going to partially work through the flag problems here. These are all problem number 1. These are all central angles, and we learned that measure of a central angle to its arc is the same. So I'm just going to recopy these so they're all in the same plane. That's 25x, and that's already 40x plus 5. That's 30. That's 90. And then, of course, right here, we have 12x plus 4. Main thing you want to watch out for is that circles add up to 360. If you keep that in mind, then we can go ahead, and as you do this, highly recommend you cross stuff out. That way you don't lose track of it. So we're going to do 25x plus 40x plus 5 plus 30 plus 90 plus 12x plus 4 equals 360. Now, when you go back and do this problem, I recommend you use some sort of physical notation to collect left terms. I usually underline all my variables and either circle or box your non-variables or something of that nature, whatever works for you, or use different colors. Collect like terms very carefully, solve for x, and then make sure you actually answer the question. You're being asked here not just for x, but for the measure of angle EFD, which is this right there. Number 4 says find the perimeter of each polygon. Assume that the lines that appear to be tangent are tangent. This is based on the simple concept that if you have a tan angle, from the vertex to the point of tangency, that's congruent. The easiest way to do these is to simply color code everything. So if you have some colors, get them handy. So we're going to darken our vertexes here. We're going to start color coding the tan angles. So we know that vertex to tangency, we know those reds are equal. Vertex to tangency, we know the purples are equal. Vertex to point of tangency, we know that the greens are equal. So if those are equal, then you can start walking around what's equal to what, and your goal is to find all these segments and then simply add them up and get the perimeter. Again, the easiest way to do this is to color code the tan angles. Number 8 is based on the same concept that whenever you have a tan angle, from the vertex to the point of tangency, those are going to be equal. So in this case, we're being asked to solve for x. So step 1, we know that this is equal to that. So you can use that to solve for x. So we have 3x minus 6 equals x plus 10. You solve for x. In this case, all you're asked is to solve for x. But on the quiz, once you have that number, I might ask you to find the red as well. And the reason is you need to remember if you have a tangent to a radius of tangent to a radius, right angle at the edge. So to find the red, once you find x, you can use Pythagorean theorem. You have a number there. You do leg squared plus leg squared equals hypo squared, and that's going to get you the red as well. That's a very good quiz question. Okay, 10 through the balance of the problems. These are all going to be the different kinds of circle angles. So let's very carefully write these out. 1, 2, 3, 4, 5, 5, 6, and 7. Okay, we learned measure of a central angle to its arc the same. Angle equals arc. Measure of a central angle to its arc the same. That's inscribed. Goes the smaller angle of inscribed is half the arc of plane. Next one, a tan chord angle is the same as the one inscribed. A chord angle's half the sum of the arcs it strikes. Secant, tangent, tan angles are all the difference of their arcs multiplied by half. It's big arc minus little arc over 2. Big arc minus little arc over 2. These are the 7 angles, and you must have this memorized. So I highly recommend put this on your paper, get it out of your reference booklet, sing the song several times, make sure you have this memorized. Ready? We're going to use this as a quick reference. In number 10, let's take a look at 10. Let's trace. Remember, we always trace, and we identify what kind of angle it is. And this is a tan angle. Now you write the equation. And that's going to be this one. Angle equals big arc minus little arc over 2. Let's make this nice and close. Okay, let's take a see what we can do here. We're in circle plug time. So we have the angle, we sweep the angle. Our angle is 77. Problem is, we don't have either the big arc or the small arc. So I'm going to call the small arc X. Now you don't want to call the big arc Y, because then you end up with another variable. So you have to define that big arc by the small arc. And we know circles add up to 360. So whatever X is, the blue arc is simply going to be 360 minus X. I'm going to pause. Make sure you understand that. Okay, now we're going to circle plug chug. So we have here our angle, and then we have the big arc we've defined as 360 minus X minus the small arc, which is just X, over 2. And cross multiply. We have 2 times 77 equals 360 minus X minus X. You're going to collect like terms. We're going to go 2 times 77 right here. That's 14. Carry the 1. That's 14, 15. 154 equals 360 minus 2X. Now you're going to take it from there and solve for X, which in this case is what you're looking for because that question mark was right there. Let's take a look at 14. We start by tracing the arms of the angle, trying to figure out what we have here. We have here a tan secant. So we write the equation. Angle equals big arc minus little arc over 2. And you circle plug chug. Ready? Angle, angle. We actually have it here. Big arc minus little arc, we don't know, over 2. You're going to complete your math from there and double check your work. So once again, the process to all of these is you trace it and you identify what kind of angle is it. And in this case, it is a secant. These ones up here, you trace them, and they are a chord. So you write its angle equals arc plus arc over 2. I'm not going to do your math for there, but that's a chord. A chord, the way I remember the fact that it's plus is the vertex is in. When you bring someone into your circle of friends, you add. This one's secant. And here we write our equation. That's going to be angle equals big arc minus little r over 2. Now we're being specifically asked to find PK, which is the actual arc. So keep in mind here, we're not just finding x. We actually want to find that arc here. So we want to find PK, which once we find x is 141 x minus 1. Keep that in mind. Ready? Now we're going to do our circle plug tug real slow here. Circle, the angle here is 45. Watch this very, very carefully. Our big arc, trace it, is 141 x minus 1. Now here's the tricky part. Minus this whole arc. You must put a parenthesis there because that's a single unit. You are minusing the whole arc. Be very careful that when you do that, you have a parenthesis there. Over 2. I'm going to help you with your math here very slowly. Make sure we're minusing that whole arc. So that's why you want parentheses around it, because it's a single entity. Put this over 1, we cross multiply. We're going to end up with 2 times 45. Now watch, I'm going to keep my colors here so you can see it. 141 x minus 1. Very carefully draw your 2 little distributive signs there. We actually have to distribute that negative sign. So we're going to go minus 51x plus 1. Now you collect like terms. Here's our variables. And here's our non-variables. Collect like terms there. Solve for x. Now don't get all happy when you solve for x, because you have to take whatever that value of x is, and you're going to plug it in to right there, 141 x minus 1, because you actually want the measure of the arc, not just x. Make sure you check your work when you're done with all those problems. This last problem says A, B, C, D, E, F, G, H is a regular octagon. Regular. Ask yourself, trace the octagon. What can I find knowing this is a regular octagon? You obviously have to think of our previous unit, Unit 6. And then you want to find all possible arc and angle measures. Show your work in the margin.